Okay, class 7. So this is part 3 of the chapter structure of matter. We have already discussed difference between compound and mixture. So today let's start with symbols. So whenever if we want to refer any element such as hydrogen, if we go on writing the name, it will be a time consuming and it will be a tedious job. Take an example. Nowadays, we use mom, okay, in place of mummy, dad in place of dad. Why? Just for the convenience. So, writing the name, full name of each and every element will be a very much time consuming job. So, the scientist or the chemist came up with an idea. Why not to use symbols in to represent any element? Why not use symbols? Now in day-to-day life we also use symbols, for what does this symbol represent? Yes, this symbol, it represent a hospital. Okay, if you see this kind of sign on the road, yes, it means you have to take a right turn. What does this means? It means you have to take a left turn. So you'll also find lots of symbols in our day-to-day life which we use. Okay, so this chemist, they thought that why not we use symbols, for representing an element. So the first person, to use the symbols was alchemist. Okay, later on John Dalton improved this symbol. Okay, we have already talked about John Dalton in the first video. So what John Dalton did was he gave symbols of elements. Okay, he gave symbols of some elements. Now if you see, these were the symbols for hydrogen. Look at the symbol. There is a symbol for carbon, oxygen, phosphorus, sulfur. So these were the symbol used for the elements which John Dalton proposed. But for few elements is okay if the elements are very few. But day by day, lots of elements started discovering. Okay, so today we have almost 118 elements. So do you think that for 118 elements it is possible for us to remember the symbols? No, it will be very much difficult for us. Okay, so later on JJ Berzelius, it will be Berzelius, not Berzelium, Berzelius. So he was the first person to propose modern day naming of the elements. So he told that why not we should use the letters, letter of the alphabet of name of the element. Okay, why not use the alphabets, from the name of the element. For example, how the elements are represented. For hydrogen was represented by H, oxygen was represented by O, and for some elements two letters were used. For example, chlorine, two letters were used, C and L. For magnesium, two letters were used, M and G. The first letter was capital and the small letter, and the second letter used is small. And for some elements, just like sodium. So don't think that the name of the sodium, the symbol used for sodium will be as. No, the symbol for sodium is Na. Now why it is Na? Because some of the names, some of the symbols of the elements were derived from its Latin name. Just see this table. For hydrogen we use H, for oxygen O, for nitrogen N, for carbon C, for phosphorus P, for calcium Ca, for cobalt two alphabet CO, aluminium Al, argon Ar, silicon Si, magnesium Mg, chlorine Cl. Now this may sound unusual for you. For sodium, Its Latin name of sodium is natrium. So what is the symbol used for sodium is Na. For potassium, its Latin name is kalium, so the symbol for potassium is K. For copper, it's cuprum. Its Latin name is cuprum, so the symbol for cuprum is Cu. For silver, it's argentinum, so symbol is Ag. For gold, aurum. Okay, the symbol for gold will be Au. For iron, ferrum, so symbol will be Fe. For mercury, the Latin name is hydrargyrum, so the symbol will be Hg. For tin, stannum, so Sn. For lead, plumbum, symbol Pb. Tungsten is wolfram, so symbol will be W. Now you have to learn all these symbols. Okay, for these elements you have to learn this symbol. It's very much important. Okay, so let's continue to the next page. So the next topic is formulae. So what is formula? Now we already know that water is composed of two atoms of hydrogen and one atom of oxygen. So how can we write the formula of any compound? Now for water, the formula will be H2O, because two atoms of hydrogen combines with one atom of oxygen. Now common salt, that is sodium chloride, what we eat is NaCl. So one atom of sodium combines with one atom of chlorine. Is that clear? Now ammonia, the formula for ammonia is NH3, means one atom of nitrogen combines with three atom of hydrogen. So in this table you can see the name of the compound and their formulas. The formula for methane is CH4. The formula for sodium hydroxide is NaOH. For calcium oxide, it's CaO. For iron sulfide is FeS. For hydrochloric acid is HCl. For carbon dioxide, it's CO2. For silver sulfide, it's AgS. Now let's see the formula of some radical groups. Carbonate, it's CO3. Sulfate, SO4. Bicarbonate, SCO3. Ammonium, NH4. Nitrate, NO3. Hydroxide, it's OH. Now you have to learn all these formulas. It's very much important, and this will be helpful in your next chapter, that is acid and bases. Okay, now let's move to the next topic, atomicity. So what is atomicity? Okay, we have already discussed that there are some atoms which remain independent or alone, whereas some atoms, they are unstable. So what they do is they combine and they form a molecule. Okay, now if you take one molecule of oxygen, you will find that there are two atoms of oxygen combine and and they form one molecule. So how many atoms do you find in one molecule of oxygen? There are two atoms. So the atomicity of oxygen will be 2. So what is atomicity? Basically, atomicity is the number of atoms present in one molecule of any element. Is that clear? Helium, neon, these are non-reactive noble gases. So they exist alone. They don't combine with another atom. So these are monoatomic, means you'll find only one atom. They will exist as a single atom. Now, some of the elements along with their atomicity is given in this table. Neon, we have already discussed, it is a noble gas or inert gas. So it doesn't combine, it is a non-reactive gas, so it doesn't combine with any other atom, so it will remain alone. So its atomicity will be 1. This is the formula. Helium is also an inert gas, so its atomicity will be 1. Hydrogen, it is a diatomic, means two atoms will combine to form one molecule of hydrogen. Same as oxygen, it's diatomic. Nitrogen, diatomic. Chlorine is also diatomic. Now phosphorus is polyatomic because four atoms of phosphorus they combine to form one molecule of phosphorus. Sulfur, 8 atoms of sulfur combine to form one molecule. So is that clear? What does atomicity means? Atomicity is the number of atoms present in one molecule of an element. Is that clear? So we have already discussed the formula of a compound. Okay, we have discussed the formula of water is H2O. Now what is the formula for carbon dioxide? CO2. Now this formula is very much important. It gives us lots of information. Now what are the information that we get from formula? The first thing is, when we look, this is the formula for carbon dioxide. Okay. So the first information what we get from this formula is, it is the compound carbon dioxide is made up of two elements. Yes, we can say that the first element is carbon dioxide and the next element is oxygen. Okay, is that clear? The first information. The second information is that here we can see that in these molecules, one atom of carbon and two atom of oxygen are present. So it also gives an idea of the number of atoms that are present in the compound. The third, it actually represents one molecule. The third information what we get is that it represents a single molecule of the compound, that is carbon dioxide. So is that clear? What information can we get from the formula of any compound? Okay. Now these are some formulas of some compounds which is given, and their atomicity is also given. Just look at this formula. Water, the formula is H2O. Here two atoms of hydrogen and one atom of oxygen is combined. So two atom of hydrogen and one atom of oxygen. So how many total atoms we have is 3. So what will be the atomicity of water? It will be 3. Hydrochloric acid, formula is HCl. One atom of hydrogen combines with one atom of chlorine. So total atoms will be 2. Its atomicity will be 2. Common salt, we have already discussed. What is this formula? NaCl. One atom of sodium and one atom of chlorine, they combine to form NaCl. So atomicity will be 2. Calcium carbonate. So calcium carbonate, here calcium, one atom of calcium, C for carbon, one atom of carbon and O3, means 3 atom of oxygen they combine. So total how many atoms do we have in calcium carbonate? One atom of calcium, one of it will be carbon. Okay, it will be carbon and 3 atoms of oxygen. So total 5 atoms. So what will be the atomicity of calcium carbonate? It will be 5. Sulfuric acid, the formula for sulfuric H2SO4. So we can see that 2 atoms of hydrogen, 1 atom of sulfate. Okay, 1 atom of sulfate. You can see this radical group. What is the formula for sulfate? SO4. So total how many atoms we have? Total is 3. So atomicity will be 3. Now let's move to the next topic, that is valency. So what is valency? Valency is actually, we have already discussed earlier that uh, some of the atoms they exist independently, whereas some atoms they combine with other atom and form molecule. So what is valency? Valency is actually the combining capacity of an element. Okay. Now why will the element combine? Yes, obviously the element will combine to form a compound, which is actually a stable state. So the combining capacity of different element are different. Take an example, calcium combines with oxygen to form calcium oxide. The valency of calcium is 2 and the valency of oxygen is also 2. And here one atom of calcium combines with one atom of oxygen. Is that clear? Okay. So here the valency of oxygen and valency of calcium are both are same in here their valency is 2. So actually they will cancel each other. And this you'll learn more about all this valency and all this formula in class 9. So in this table, carbonate, symbol of carbonate is CO3, valency is 2, aluminum it's Al, the valency of aluminum is 3, phosphate its symbol is PO4, valency is 3. So why the valency of aluminum is 3, you will study again in class, you'll study in class 9 when you'll learn about all those electronic configuration and all. So for the time being, just you have to remember this symbols and their valency. There are some elements which show dual valency. Okay, just like nitrogen, they show dual valency 3 or 5. Iron also show dual valency 3 or 5. Copper, copper also show dual valency 1 or 2.